guys. Okay, so this is week 7, and I am going to be posting along with this video another Google form that you'll have to do, and this is going to be week 7 practice problems. Okay, so I think there's about 8 of them. What I'm going to do right now is I'm going to, you'll see in a second, I have the whiteboard over here, but I'm going to go over a couple practice problems that's going to help you solve the problems on your Google form. Okay. So I'm going to try and do it kind of quickly just to do some quick review. This is all stuff that you've learned already, so it shouldn't be super challenging. But we're going to just practice a couple things and go over a couple of the skills and concepts for these set of practice problems. Okay, so let me just position this so that you can see my whiteboard. Okay, I think that's good. Okay, so we're going to look at, if you notice, there's some addition and subtraction with decimals. And we are going to use order of operations by reading left to right. Okay, but first let's read these numbers, practice reading these numbers in decimal form. We have 12 and 1/10 plus 5 and 241 thousandths minus 8 and 97 hundredths. Okay, so the biggest rule we have to remember, adding and subtracting decimals, super easy. We just need to line up the decimal. Okay, so I'm going to start with, like I said, we're going to read left to right. We're going to do a little bit of order of operations as well. I'm going to take 12 and 1/10 and line it up with 5 and 241 thousandths. And then, of course, what I like to do is I like to add the zeros so I can keep my place. Okay, so now I'm just going to add 0 and 1 is 1, 0 and 4 is 4, 1 plus 2 is 3. The decimal stays in the same spot. 2 plus 5 is 7. And we get 17 and 341 thousandths, which is great, but we're not done because we still need to subtract 8 and 97 hundredths. So I'm going to take 17 and 341 thousandths, and I'm going to subtract 8 and 97 hundredths, adding a 0 to keep my place values lined up. So I can do 1 minus 0, I get 1, but I cannot do 4 minus 7. So we borrow from the 3. 14 minus 7 is 7. 2 minus 9, again, I can't do, so I am borrowing. This becomes a 6, this becomes a 12. 12 minus 9 is 3. 6 minus 8, again, I cannot do, so I am borrowing. 16 minus 8 is 8. Decimal stays in the same spot, so I get a final answer of 8 and 371 thousandths. Okay, I'm going to just pause Okay, the next skill we're going to go over is writing some decimals into Word and expanded form. So for this number here, the way we say the number is exactly how we write the number in word form. So if I wanted to say this number, I'm going to say 908, just 908. And then when we get to the decimal point, that means we say and. So 908 and 64 thousandths. The 4 is in the thousandths place, and that's why I have to remember to say thousandths at the end. Wherever the digit ends, whatever place value it ends in, that's what we say. So if this were just here, this would just be 908 and 0 tenths. If it ended here, this would be 908 and 6 hundredths. And then obviously here, 908 and 64 thousandths. So that would be 908 and it's very important to put the word and there. Okay, so 908 and 64 thousandths. And again, it's important to put the THS at the end of the word to show that you are doing decimals. Now, expanded form is we're going to take each of the digits and we're going to expand it. Now, remember, there's a couple different ways you could do expanded form, and they're all correct, okay? But we like to do the more 5th grade way, which is expanding it a little bit more. So 9, yes, it's in the hundreds place, but that means we're going to write 9 times 100. And then we're going to add it with, well, we can skip the 0 because there's nothing there. So we're just going to go to the 8 and we'll put 8 times 1. And then we're going to add it with, now we can skip another digit. We can skip the 0 here, and we're just going to go to the 6. Now, remember learning this in school, it's going to be 6 times, well, it's in the hundredths place, so we're going to make the fraction 1/100th. Okay, and then the 4 is in the thousandths place, so 4 times 1,000th. Okay, so just a quick review on how to put standard form into word form and expanded form. You can also take expanded and put it into word and standard, and word can be turned into standard and expanded form. Okay, this is just one of the ways and one of the practice problems I am showing you. Okay, on to the next one. Okay, the next problem I'm going to show you is let's kind of give this a word problem to help us out a bit. Let's pretend I had 3 pieces of construction paper, okay? So this rectangle here represents a piece of construction paper. But let's pretend that I have 3 pieces, okay? So I'm going to write this up here to help us remember, okay? But this is just one piece, and I want to know the area of the construction paper. So I see that it is 9/10 of a foot by 1/2 of a foot. So this would be length times width. So if I wanted to find the area, right, we know that that is length times width. So if I wanted to find the area of this piece of construction paper, I'm going to take 9/10 and multiply it with 1/2. Now, if you remember, when we multiply fractions, we simply just have to multiply across, right? We can check to see if we can cross cancel, but if you notice, we actually can't cross cancel, so I'm just going to multiply. So 9 times 1 is 9, and 10 times 2 is 20. Okay, so we have 9/20, and that would be feet squared, because we're talking about area. So this is the area, though, of one piece of construction paper. However, I know that there are 3 pieces. So I'm going to have to take the area of one piece of construction paper and multiply it by the 3 pieces. Now, if you remember, if I'm multiplying by a whole number, I need to put the whole number over 1. And once again, I want to check to see if I can cross cancel, okay, which I can't because 20 and 3, I can't divide by anything that's the same. So I'm going to just multiply across, and we get 27/20. 27/20 is an improper fraction, so we need to turn it into a mixed number. So you can divide on the side, but some of you I know are pretty good at this, but you can do 27 divided by 20. It goes in once, and we get 7 as a remainder. Okay, if you can do it in your head, that's great. We get 1 7/20 feet squared for 3 pieces of construction paper. So the final answer is actually going to be 1 7/20. Even though 9/20 is a good answer, but remember that's only for one piece of construction paper and not 3 pieces. Okay, so that would be a similar word problem that you might see when you work on your Google form. Okay, on to the next practice problem. Okay, the next problem, I'm going to kind of do a real world example with something that you might actually face while you're doing your assignments at home. So let's say you have 3/4 of an hour, which equals 45 minutes, but we'll leave it as a fraction for right now. Let's say you have 3/4 of an hour and you need to complete 2 assignments. So you want to know about how much time you can spend on each assignment. Okay, so you have 3/4 of an hour, you have 2 assignments. What are you going to be able to do on each assignment? So that is going to be division. Okay, so we have to take the 3/4 of an hour and we need to divide it by the 2 assignments. Okay, now if you remember when we learned fractions, we have to do LCR. And if you remember what that means, it's going to be leave, change, and then we take it's a scary word, but it's not so bad, the reciprocal of the final number. So that means we leave 3/4 alone. We change division to multiplication, and we take the reciprocal of 2. Well, remember 2, it's like saying 2 over 1. So the reciprocal, we just flip, and we take the reciprocal, which is 1/2. Then I simply can multiply across again. Of course, it's good to check if you can cross cancel. We can't, okay? But 3 times 1 is 3. 4 times 2 is 8. So that means you can spend 3/8 of an hour on each assignment, okay? That in order to do it fairly and so that you don't run out of time, okay? Next question. Okay, this one is supposed to be easy, but it does get a little tricky. So we have 2,439. Okay, if I wanted to write this number in expanded form, it's super easy, right? We have 2,000 plus 400 plus 30 plus 9, right? Super, super easy. But let's say instead of writing it like this, I actually want to write it a little differently. I want to write it using 14 hundreds. So this is going to change my answer a little bit. So instead of writing 4 here, I want to use 14 hundreds. So I want to use 14 hundreds here. Okay, so that's going to change some things. I can't just use 14 hundreds. I can't just borrow 1,000 and not do anything with it. So if I want to use 14 hundreds here, I can, but that means I actually have to borrow from the 2 and actually make it a 1 if I'm going to use 1,000 there from the 4. Okay, so that's actually going to change my 2,000 to actually only 1,000 plus the 1,400, right? Or 1,400 plus 30 plus 9. Okay, so these are actually 2 different ways, but if you were to actually add both of those answers together, you're going to get the original number of 2,439. So either one is correct. You're not going to see it too often this way, but sometimes problems might be a little tricky and they might ask for it in a different way, and this would be the different way, and it still means the same thing. You're still ending up with the same answer, okay? Okay, the next kind of problem you're going to see is just a simple multiplication problem, but this is kind of a big one. This is a 4-digit number multiplied by a 3-digit number. So we have to remember the steps in order to do this correctly. Okay, so we'll start with the digit 6. Okay, it's in the ones place, so I can just multiply normally. 9 times 6 is 54. I'm going to bring the 5 up. 6 times 4 is 24, plus 5 is 29. 6 times 2 is 12, plus 2 is 14. 6 times 1 is 6, plus 1 is 7. And we get 7,494, and that's actually called our first partial product. But we know we are not done because we need to move on to the next digit. We want to move on to the 1. But the 1 is in the tens place, which means I need to add a 0 before I can continue. Okay, so I'm now on the digit 1. I want to cross off these numbers so I don't get confused. 1 times 9 is 9. 1 times 4 is 4. 1 times 2 is 2. And 1 times 1 is 1. So that was actually an easy one because there was a 1 there. Now I want to move on to the digit 3. But the 3 is in the hundreds place, which means I actually need to add 2 zeros. Okay, now I can continue. So 3 times 9 is 27. 3 times 4 is 12, plus 2 is 14. 3 times 2 is 6, plus 1 is 7, and 3 times 1 is 3. So this would be the first partial product, the second partial product, and the third partial product. Now, once I have all of them together, all I have to do is add them. We get 4. 9 plus 9 is 18. Carry the 1. 4 and 4 is 8. 9. 9 and 7 is 16. 1 and 2 is 3. Plus 7 is 10. And 4 is 14. 9, and 3. So this is a pretty big number. We actually get 394,684 as our final answer. Okay, we only have a few more problems to do. Let me just pause. Okay, the next problem the next practice problem that's going to help you, we have 10 to the 0 power, 10 to the first power, 10 to the second power, 10 to the third power. So remember, these are called exponents. Well, the little number is called an exponent. The bigger number is a base. And when the bigger number, the base, is a 10, exponents are super easy. The exponent tells you how many zeros you need to put. So you don't even really have to know exactly what the exponent represents. You just kind of have to know, okay, 0 means there's 0 exponents. So 10 to the 0 power is equal to just 1. 10 to the first power means there's 1 0. So that equals 10. 10 to the second power is 2 zeros, and 10 to the third power is 3 zeros. Okay, so what it means though, because this is good to know, all right, 10 to the 0 power is just 1. That one doesn't really mean anything, but 10 to the first power just means we are just taking 10. Okay, just 1 10. This is 0 10, so we don't have any. This one is 1 10. The 2 here technically means that we are doing 10 times 10. There are 2 10s. And 10 to the third power actually means that we are doing 10 times 10 times 10. Okay, and just remember, there's some misconceptions here. Please, please, please do not tell me that 10 to the third power is 30. It is absolutely not 10 times 3. 10 to the third power is actually 10 times 10 times 10, which is 1,000, and that's because 1,000 has 3 zeros, where the exponent is 3. Okay, and this can be applied all here too. So 1, 2, 2 10s, 1, 2, 2 zeros, the exponent is 2. We only have 1 10, so we don't even have to multiply it out. 1 10 has 1 0, exponent is 1. 1 has no zeros, and the exponent is 0, so there shouldn't be any zeros. Okay, just a quick review on exponents. Okay, the last one that we're going to review is a subtraction with fractions. Okay, so adding and subtracting fractions follow the same rules. Okay, we need to, when they have different denominators, we need to make sure that we get a common denominator. Okay, so there's a couple ways you can do this. You can think of your multiples of 5 and your multiples of 4 and come up with your least common multiple. Okay, or you can multiply the denominators together. Now, that doesn't always give you the least common denominator. In this case, it will, but it doesn't always. So sometimes listing out your multiples isn't a bad idea. So to list out multiples, just so we know how to do this, 5, 10, 15, 20, 25. That would be my multiples of 5. My multiples of 4, 4, 8, 12, 16, 20. Now I can actually stop because they have the least common multiple is 20, which means that's going to be my least common denominator, which happens to be if I multiply the two of them together. Okay, so I'm going to multiply 5 by 4, and what I do to the denominator, I have to do to the numerator. What I do to the denominator here, which would be multiplied by 5, I need to do to the numerator. So my fractions are going to change a bit. I'm going to get 16 20ths minus 15 20ths. So now that they have a common denominator, now I can continue subtracting. So 16 minus 15 equals 1 20th. Okay, and the same rules apply for adding fractions as well. Okay, so don't forget about that. All of these review problems should definitely help you with week 7 problems. Okay, and again, as always, if you still have any questions or you need help with anything, please email me. Our Google Hangouts will still be scheduled for Wednesdays as usual. Each class is a little different, so just check your Google Classroom for the time that you're going to do. Okay. Again, have a great day, and thank you for watching the video.